Hello and greetings to everyone. We are to answer the following exercise for application. Question 1 says convert the units of the following speeds as indicated. For A, we are to convert 62 kilometers per hour to meters per second. We take solution. Question 1. A, we are to convert 62 kilometers per hour to meters per second. 62 kilometers per hour is equal to 62 kilometers all over 1 hour. This is simply equal to 62 times, 1 kilometer is equal to 1000 meters divided by 1 hour is the same as 60 times 60 seconds, since we know 60 minutes make 1 hour and 60 seconds make 1 minute. We can proceed with the simplification. Carrying out simplification, these two zeros will strike off 2 zeros here. 2 will go into 10 5 times, 2 will go into 6 3 times, 2 will go into 62 31 times, 2 will go into 6 here 3 times. This will simply be equal to 31 times 5, which gives us 155 all over 3 times 3, which gives us 9 meters over seconds. Meters over seconds is the same as meters per second. So this is the speed, 22 kilometers per hour to meters per second. For B, we are to convert 6000 centimeters per second to meters per second. E, 6000 centimeters per second to meters per second. This will give us 6000 centimeters per second to be equal to 6000 centimeters all over 1 second. First, we know 100 centimeters is equal to 1 meter. We take 6000 centimeters in meters, it will simply be equal to 6000 divided by 100 meters, and this will be equal to 60 meters. Therefore, if we take 6000 centimeters per second, it will simply be equal to 60 meters all over. We are going to replace this 6000 centimeters with 60 meters all over 1 second. And this will simply be equal to 60 meters per second. We go to question C. For C, we have to convert the speed of 720 meters per second to kilometers per hour. 720 meters per second is simply equal to 720 meters all over 1 second. First, we know 1000 meters is equal to 1 kilometer. Now we have to convert 720 meters to kilometers. For us to convert 720 meters to kilometers, we are simply going to divide 720 by 1000. The unit will be kilometers. This will simply be equal to, these zeros will strike off. The highest common factor of 72 and 100 is 4. 72 divided by 4 gives us 18 all over 100 divided by 4 gives us 25. This will be equal to 18 all over 25 kilometers. Next, we have to convert 1 second to hours. Let's do the conversion. We know in 1 hour, we have 60 times 60 seconds to make 1 hour. This will give us 3,600 seconds to make 1 hour. Now we have to express 1 second in hours. 1 second in hours will simply be equal to, we are going to divide 1 by 3,600. The unit here will be hours. Now for us to express the speed of 720 meters per hour to kilometers per hour, it will simply be equal to, we are going to replace 720 meters with 18 over 25 kilometers, and we are going to replace 1 second with 1 all over 3,600 hours. 18 all over 25 kilometers all over 1 all over 3,600 hours. This will simply be equal to 18 on 25 kilometers times, we are going to invert the last fraction. This will give us 3,600 all over 1, and the hour will be at the denominator as such. Now we have to perform the necessary simplifications. If we divide 3,600 by 25, it gives us 144. 25 divided by 25 gives us 1. This will be equal to 18 times 144 is equal to 2,592 kilometers. The hours is at the denominator per hours. Therefore, the speed 720 meters per second is equal to 2,592 kilometers per hour. We go now to question 2. Question 2 says find the speed of bodies that move as indicated. For A, first we know speed, which is denoted by s, is equal to distance traveled denoted by d divided by the time taken. For question A, we have been told that the body travels a distance of 500 kilometers and the time taken is 7 hours. We have to calculate the speed. In this case, we are going to calculate the speed in kilometers per hour. So this will simply be equal to, we are going to divide the distance traveled, 500 kilometers, all over the time taken, which is 7 hours. And this will simply be equal to, we are going to leave the speed as an improper fraction, since 7 is not a factor of 500. This will give us 500 all over 7 kilometers per hour. This is the speed of the body. We go to B. The body travels a distance of G, 600 meters, and the time taken is T equal to 10 minutes. We have to calculate the speed. The speed of the body will simply be equal to, we are going to divide the distance traveled, 600 meters, all over the time taken, which is 10 minutes. And this will be equal to 600 divided by 10 gives us 60. And the speed will simply be meters per minute. This will be the unit of the speed in this case. We go now to question 3. It says find the distance traveled in meters by objects moving at for a speed of 65 kilometers per hour for 3 hours. We have to find the distance traveled. From s, speed equal to distance traveled over time taken, we can make distance traveled the usual formula, and the distance traveled will simply be equal to the speed of the object times the time taken. For A, we have been told that the object travels at a speed of 65 kilometers per hour, and the time taken by the object is 3 hours. The distance traveled will simply be equal to, you're going to multiply the speed 65 kilometers per hour by the time taken, which is 3 hours. This will give us 65 times 3, which is 195 kilometers per hour times hours. Hours will strike off, we'll be left with kilometers. The distance traveled by the object is 195 kilometers. For question B, the object travels at a speed of 28 meters per second for a half hour. Speed of the object is 28 meters per second, and the time taken t is equal to a half hour. First, we are going to start by expressing the time taken in seconds. T is equal to a half hour. We know an hour is equal to 60 times 60 seconds. For us to express a half hour, we are simply going to take a half of 60 times 60 seconds. And this will simply be equal to a half of 60 times 60. 60 times 60 gives us the number 3,600. 3,600 times a half gives us 1,800 seconds. This is a time taken by the object. Now we can proceed to calculate the distance traveled. The distance traveled by the object will be equal to the speed of the object, 28 meters per second, times 1,800 seconds. Let's perform the multiplication. This will be equal to 28 times 1,800. This will give us 50,400. The seconds will cancel, we'll be left with meters, which is simply the same as, we divide by 1,000, this will give us 1, 2, 3, gives us 50.4 kilometers. This will be the distance traveled by the object in kilometers. Question C. The object travels at a speed of 4 times 10 to the power 5 centimeters per second for 2 minutes. The speed of the object is 4 times 10 to the power 5 centimeters per second, and the time taken is 2 minutes. 2 minutes in seconds is the same as 2 times 60 seconds, which is 120 seconds. Now for us to get the distance traveled, we are simply going to multiply the speed of the object by the time taken. 4 times 10 to the power 5 centimeters per second times 120 seconds. To perform the multiplication, 4 times 120 gives us 480 times 10 to the power 5 centimeters per second times second gives us centimeters. We can express this as 480 10 to the power 5 simply means we are going to attach 5 zeros to this number. We attach 1, 2, 3, 4, 5, and the unit is centimeters. For us to change from centimeters to meters, we are going to divide by 100. Dividing by 100, 2 zeros will go off. We'll be left with 1, 2, 3, 4. We'll be left with 480,000 meters. 480,000 meters in kilometers. If we divide by 1,000, 1, 2, 3 zeros will go off. We'll be left with 480 kilometers. This will be the distance traveled by the object in kilometers. You can still leave your answer in centimeters, the distance traveled in centimeters, or you can still leave it in meters. But giving it in kilometers is more preferable than writing a long number. We move now to question 4. A cyclist travels 25 kilometers at 20 kilometers per hour and then a further 80 kilometers at 25 kilometers per hour. Find the total time taken for the whole journey. From S equal to D over T, if you make T the subject of the formula, the time taken, T will be equal to D divided by S. Divide the distance traveled by the speed. In this question, we have been told that the cyclist travels 25 kilometers at 20 kilometers per hour. We are going to use S1 to stand for the speed of the first phase of the journey, which is 20 kilometers per hour. And D1 for the distance traveled in the first phase of the journey, which is 25 kilometers. Now we can proceed to find the time taken in the first phase. T1 will be equal to D1 divided by S1, and this will be equal to 25 kilometers divided by 20 kilometers per hour. This will simply be equal to, if we perform all the necessary simplifications, 5 is the highest common factor of 25 and 20. 25 divided by 5 gives us 5 all over. 20 divided by 5 gives us 4. Kilometers divided by kilometers per hour, this will give us the time taken in the first phase is 5 all over 4 hours. Now let's find the time taken in the second phase. In the second phase, the cyclist had a speed of S2, which is equal to 25 kilometers per hour, and the cyclist covered a distance D2 of 80 kilometers. Now we need to find T2, which is the time taken for this phase. We are going to divide D2, the distance covered, by S2, and this will be equal to 80 kilometers all over S2, which is 25 kilometers per hour. Now, performing all the necessary simplifications, 5 is the highest common factor of 80 and 25. 80 divided by 5 gives us 16 all over. 25 divided by 5 gives us 5. Kilometers divided by kilometers per hour, we're left with hours. So the time taken by the cyclist for the second phase is simply 16 all over 5 hours. Now we need to find the time taken for the whole journey. The time taken for the whole journey, T, will simply be equal to T1, time taken for the first phase, plus T2, time taken for the second phase. And this will be equal to T1 is 5 all over 4 hours, plus T2, which is 16 all over 5 hours. This will simply be equal to, we find the LCM of their denominators. The lowest common multiple of 4 and 5 is 20. 20 divided by 4 gives us 5. 5 times 5 is 25. Here we have 25 hours plus 20 divided by 5 gives us 4. 4 times 16 is equal to 64. Here we have 64 hours. This will simply be equal to 64 plus 25 gives us 89. 89 all over 20 hours. This is the time taken by the cyclist for the whole journey in hours, of which we can decide to express this as a mixed fraction. Expressing this as a mixed fraction, this will give us 4 and 9 all over 20 hours. 20 times 4 gives us 80. 80 plus 9 gives 89 all over 20 hours. This is the time taken for the whole journey. B is asking us the average speed of the whole journey. B, the average speed of the whole journey, we are going to denote it as S average. It will simply be equal to, we are going to divide the total distance covered, alright, that's T total all over the total time taken for the whole journey, which is T. This will simply be equal to the total distance for the whole journey. You know, for the first phase, the cyclist covered a distance of 25 kilometers plus, for the second phase, the cyclist covered a distance of 80 kilometers. We divide by the total time taken, which is 89 all over 20 hours. 25 plus 80 is simply equal to 105. Numerator, we have 105 kilometers divided by 89 over 20 hours. This will simply be equal to 105 kilometers times 20 over 89. Hours will be at the denominator as such. And this will be equal to 105 is over 1. Looking at what we have at the numerator and at the denominator, we cannot perform any simplifications. We are simply going to multiply what we have at the numerator, 105 times 20. It gives us 2,100 kilometers all over 1 times 89 at the denominator is 89 hours. This will simply be equal to 2,100 over 89 kilometers per hour. So this will be the average speed of the cyclist for the whole journey. We go now to question 5. Question 5 says Ndifo can drive to school in 15 minutes if he travels at an average speed of 35 kilometers per hour. How long will his journey take if he drives at an average speed of 45 kilometers per hour? Question is very interesting. First, we are going to start by finding the distance covered to school by Ndifo if he drives for 15 minutes. By making use of S equal to d over t. Then we know the distance covered is simply equal to s times t. From the first part of the question, we have been told that if you can drive to school in 15 minutes, that means the time taken to school is 15 minutes. If he travels at an average speed, we're going to take the speed as 85 kilometers per hour. The speed 35 kilometers per hour can be expressed in kilometers per minute so that we can easily calculate the distance. This will be equal to 35 kilometers all over 1 hour, which is simply equal to 35 kilometers all over 1 hour. In minutes, we have 60 minutes. This will be equal to 35 divided by 5 gives us 7 all over 60 divided by 5 gives us 12 kilometers per minute. So this is the average speed of D4 in kilometers per minute. Now we can calculate the distance traveled by D4 from the house to school in 15 minutes time. This will simply be 7 all over 12 kilometers per minute times the time taken, which is 15 minutes. 15 over 1. I write it as such. Now if we simplify, 15 at the numerator and 12 at the denominator, the highest common factor of 15 and 12 is 3. 3 will go here 5 times. 3 will go into 12 4 times. This will simply be equal to 7 times 5 gives us 35 all over 4 times 1, which is 4 at the denominator. Kilometers per minute times minutes. The minutes will cancel. We'll be left with kilometers. That means the distance traveled from home to school by D4 in 15 minutes is 35 all over 4 kilometers. Now we are required to find how long will his journey take if he drives at an average speed of 45 kilometers per hour. Now let's assume he makes use of a speed of, in this case we are going to denote this speed by s prime, an average speed of 45 kilometers per hour. Now the distance from his home to school is 35 all over 4 kilometers. Now we need the time. You know, time is equal to the distance traveled all over the speed, and this will simply be equal to the distance traveled from home to school is 35 all over 4 kilometers divided by the average speed of D4, which is s prime. Average speed is 45 kilometers per hour. This will simply be equal to 45 kilometers per hour. We can write 45 here as 45 over 1. This will give us 35 over 4 kilometers times 1 all over 45 kilometers per hour, which is at the denominator. Hours will go up and kilometers will go down as such. Kilometers will cancel kilometers. You'll see we'll be left with hours, which is a unit of measuring time. Now we can proceed with the simplification. The highest common factor of 35 and 45 is 5. 35 divided by 5 gives us 7. 45 divided by 5 gives us 9. This will simply be equal to 7 times 1 gives us 7 all over 4 times 9, which gives us 36. 36 hours. We'll be left with hours. Therefore, the time taken by the to travel from home to school if he drives at an average speed of 45 kilometers per hour is simply 7/36 hours. You can see decide to express this time in minutes. This time in minutes will simply be equal to, 1 hour is equal to 60 minutes. Then if you take 7/36 hours, this will simply be equal to 7/36 times 60 minutes. And this will be equal to, performing all the necessary simplifications, the highest common factor of 36 and 60 is 12. 60 divided by 12 gives us 5. 5 times 7 gives 35 all over 36 divided by 12 gives us 3. So this will give us 35/3 minutes. So this is the time taken by default to drive from home to school. We are done with the correction of the exercise for application. If in case you have any worries, you leave your questions at the comment section. Please like the video, share, and subscribe to this channel. Thank you very much for watching.